Welcome back. In this video, I just want to get us set up with our basic skeleton, our two classes. So we'll have a binary search tree class and then a node class, just like we did with a linked list. We had the linked list class and then a node. So a binary search tree itself really only has one important property, which is the root. And then each node has a value, but instead of having a .next or a .previous, we have a left and a right. So I'll quickly code this up. I'll fast forward through some of it. So our constructor takes a single value in, and we just set this dot value equals value, and then this dot right. I like to do the left first. I don't know why. And this dot right. It doesn't matter at all. Okay, so that's our single node. Now we'll just make our binary search tree. You could just do BST if you prefer. And inside of that, we'll have our constructor. It doesn't take anything. You could have it take an initial value and create the node if you wanted to, but we won't do that. And we'll just do this dot root equals null. Now with this, we could construct our own basic BST. I could say, var tree equals binary search tree. Oops, I need to say new binary search tree. And then we could do tree dot root equals new node, let's say with the value of 10. And then we could manually say tree.root.right equals new node. So it needs to be greater than 10, let's say 15. Tree.root.left equals new node of what's something less than 10? How about 7? And we could keep going. I'll just do one more level. Let's do tree.root.left.right. So this needs to be less than 15 because it's to the left of it, but it also needs to be greater than 7. So let's say, it needs to be less than 10 and greater than 7. So let's go with 8, actually 9. I like odd numbers. And this sets up a simple binary search tree, although it's a huge pain to insert things like this. So just like we did with a singly and doubly linked list, what we're going to add is a method called insert. And it will figure out where something goes based off of comparisons. Oh, this needs to be new node 9. Not sure what I was doing there. Let's run it and just make sure it works. If we look at our tree, okay, we've got tree.root. I mean, there's not much for us to really check at this point, but we have some nodes that are connected. Each node has a value, a left and a right. Okay, in the next video, I'll explain how insert should work, and then we'll get coding.